All right, Internet, we're back at it again. So today we're going to go through this challenge level 16 called Preservation. Now, preservation, let's read the challenge. So the challenge states that this contract utilizes the library to store two different times for two different time zones. The constructor creates two instances of the library for each time to be stored. The goal of this level is for you to claim ownership of the instance you were given. Then it gives you some tips and things you should contemplate or think about when trying to solve the challenge. Now, the good thing about this challenge is it's basically it's a regurgitation of a few others. So when we were working through, I think it was privacy, maybe? This one, maybe? Yeah, privacy? Something like that. There's a few in here that we did, challenger levels, that had different things that are relevant for this challenge here. One of which is delegate call. Another one is storage, of how things are stored and where they're placed and how to access that. So really, if you can understand how we solved the previous challenges, then you'll understand kind of what's happening here. So we'll quickly review things that we've reviewed historically, but we'll be kind of brief with that. So go back and see the other stuff. But yeah, so this is a pretty straightforward challenge. And I did cheat a bit because, you know, it's not fun if you don't cheat, I guess. It's a bad motto. Anyway, so that's our challenge. This is preservation, and let's start with the notes. Now, some of the places or some of the groups of people I cheated from were listed here. So Web3 Dev Dude, so the video series that he's created on Ethernaut, I use this to actually help me with a lot of stuff to really get an understanding of how this was solved. But previously to actually going to his videos, I checked Zero Sage. I read through some of this content, and it made sense around why the challenge was solved the way it was, but I didn't necessarily connect the dots around the last two steps of how we'll solve it together. One here, you can actually see that they mention the two levels where this is relevant. So you can see level 6 and level 12 are the two levels that will help you with taking the ideas from those and combining them into this challenge, because this is really just a more advanced way of leveraging delegate call and storage to manipulate the contract and for us to exploit it. So in here, they do a great job at explaining some stuff. I like the intuitive images they provide to understand how storage works and how delegate call functions. So that's definitely something you should kind of check out and get a better understanding around those two concepts. Another individual I wanted to call out here did a pretty good job at explaining some concepts, and the way that they solved it was interesting and slightly different than from the others. But it's super short read, not super detailed, but useful. So those are the resources that I used to cheat. And here's a beautiful library that I pulled from deviantart.com. So you should check that out because it's a really great anime art there. Alrighty, so to get into this challenge, I think the first thing I'm going to do is talk about the main takeaway, which is stated here. And the main takeaway from this challenge is simply, when utilizing libraries or creating libraries, ensure that the function that's going to be the library is labeled as such. Because currently in 8.0 with Solidity, when you label something as a library, that puts certain restrictions on that function, allowing it not to store state, and it's also not allowed to store ether. So state and ether. And that prevents some of the issues that we're going to take advantage of here. Additionally, the storage slots are a big thing that's going to help us to understand specifically how storage slots function, where they sit, all that stuff. And those are really the two main takeaways from this challenge. Another big takeaway that I'll scroll quickly down to for, I think it's down, where is it? Here. So this part here, I wanted to call out for libraries that in the documentation, it specifically states that when you label something as library, then it does the two things I mentioned above, where it basically states you cannot hold state variables and you cannot store ether in those functions that are labeled as library. And people use libraries for many different reasons. It's beneficial to use libraries so you can standardize. So let's go away from this so it's not distracting really quick so I can explain this point. When using libraries, it's useful because you want to standardize certain types of functionality. So authorization, authentication, doing different types of event emissions, so emitting certain standard events that you want to kind of I guess capture on your off-chain products and off-chain applications. There's a series of things that people do that are common reoccurrences, and that's why a lot of libraries exist in programming languages, but also in concepts like Kubernetes with sidecar. So if you're big onto DevOps and stuff like that, there's sidecars that are within the the Kubernetes ecosystem and all that stuff. So that's a different conversation. But there's these centralized frameworks, or not centralized, but standardized frameworks that can be utilized in multiple use cases, and that's what libraries are useful for, and that's why we want to use them. But when using libraries, you want to ensure that those libraries really just focus on doing specific types of computation and not storing any data, but doing the computation on the data that's sent to it. So that's kind of the big concept around libraries and how you should label them as libraries and not store data inside of them. So with that being stated, let's work through some more of the notes to talk through storage and how that works. So like I said, in the previous challenges, I've talked about this already. So I've linked that here, so I'll link this in the description, but this link here is basically taking you to another video, level 12 for privacy, which talks you through storage in depth, and more in depth than I'm going to do here. But high level storage in Solidity is based off of different slots, and each slot takes around 256 bits, which is I think 32 bytes. And depending on the size of the state variable that you're storing, you may actually smash more variables into one slot instead of having each variable have its own slot. For example, we can see this first item here, the foo, is being stored here because it's bytes 32. So that's 32 bytes, which takes up the entire slot. So you can't put any more variables in that slot that exists. Same thing applies for bar. That's a 32 byte, so it's going to take up the entire thing, and the color coding helps here. So we can see here that the uint num is only taking up this back portion here, 7b. But since it's uint, there's no specifier here. So when you don't specify something with the state variable with uint, it's automatically going to put that as a 256 bit. So it's going to take up the entire slot, even though it's only taking up this last piece here. So this is very gas inefficient. That's going to cause costly issues in the future. Additionally, here you can see the address for the yellow piece. This here is taking up not the entire piece. So this is just half of the 32 bytes or half the 256 bits. So that means that our Boolean here, which is usually just binary, 1 or 0, it's only going to take up a small percentage or a small part of that slot, can be smashed up against that address and save ourselves gas. So ideally, if someone was actually coding this up in Solidity, this uint num, they would maybe want to specify this uint size if they knew the number length that it was going to be. So if they knew this could be a uint 8, they could have put uint 8 here and then put in the address in there as well, and then maybe even the Boolean to save themselves gas and save themselves an entire slot. So that's kind of the concept around storage and how their different state variables can be smashed together in certain slots. Another really important thing to point out here is that with these slots, these are all labeled as numbers. So this is going to be slot 0, this is going to be slot 1, this will be slot 2, and then this will be slot 3. Now, if we know the slot numbers, then we can actually utilize a web util, get storage here. We can use this to peer in and look at those specific storage variables that are being stored and what the associated values are. And that's how we cracked privacy, because we realized that things that are labeled as private, state variables that are labeled as private inside of the Ethereum chain, you can actually see that by utilizing tools from Web3, Web3.js, not Web3 like the general term. All right, so that's storage. The next thing here is, so get storage at, this is something we've already touched on, and I'm not going to dive deep on this because we're just going to use it quickly. But if you've not watched the previous videos for privacy and things like that, I recommend just going to the documentation and getting an understanding of how this method basically is utilized and what stuff goes inside of that method, so you can get the interesting information you want to get out of it. Below that, what else do we have? A video that I linked out to that I'll share with you. So there's all kinds of links in here that are going to be in the description that I've talked about historically. But this is going to basically walk you through how to access private data, and it talks specifically through the get storage at piece. Libraries, already talked about that. Delegate call. Okay. So this is the next big portion of the hack. So we have the storage layout and we have the delegate call, the two big pieces here. So delegate call. There's a series of links here that I've put out that I would recommend you check out. So this is basically the smart contract programmers explaining delegate call generally, not the exploitation for it, just 8.0 and how it works. There are this is a two-part series of hacking and using delegate call to hack from the same YouTuber. It's a good one. This is an explainer from a blog that walks you through a delegate call and how it functions. That's a good one that I've read. And then the docs. So the docs are super short, at least the one that I've linked here. So it's just a few sentences kind of summarizing what delegate call is and how it works. But instead of just explaining it via text or verbally, I have some graphs here. So I stole this little snippet from the video here that you should check out. He does a great job at explaining it this way, but instead of explaining it here, I'm going to explain it through these different charts that I've explained already in another challenge. All right, so really quick, a regular call, how it usually functions is as such here, right? So we have an externally owned account, which is a human, and they're going to do a call to a contract. So you're calling a contract. And here you can see that the sender is going to be the externally owned account, which is the human, and the value is going to be whatever they put in there. So that's going to come into this contract 1, and we have contract 2. Now, as you're going through this contract, after you've called this contract, it's going to do a few things, and then going to call another contract to complete the execution. And when it's doing this additional call, you can see that the sender here has changed, and now it's the caller, which is the contract, and the value has changed associated to that contract. So it's everything changes as it goes through each one of these gates in a traditional call when you're targeting different calls or different contracts. But a delegate call, as you can kind of intuit from the name, is you're delegating the call. So here we have the same process. So we have our human, externally owned account, then we have our call, and then a few other things. So we're making our call here into contract 1. We have contract 2. Now this is the same as last time. So we have the EOA, and so the sender and the value are associated to our EOA. But when we run through contract 1 and they do their execution, and then they do an additional call to this contract to finish the execution, they're actually delegating the call. And when they delegate the call, the sender is still going to be the EOA here, and the message value is still going to be the EOA that they set up. So we're basically passing through this contract, running a series of executions, and then moving on to the next contract, but it's still preserving context and preserving state. And that's a few terms that you'll see when you read or watch videos. You'll hear people talk about preserving context. And they're basically preserving the context of this EOA here as they're going through each one of these gates, each one of these contracts. And that's kind of the intuitive high-level understanding of what delegate call is and it does. So with that being stated, we should go to the contract code. And what I'll do here is I'll walk you through the code and explain specifically what's happening here, and how all the stuff we just discussed is going to help us attack this contract. So starting out, per usual, we have our compiler version here, 8.0, floating point. So remember, we want this not to be floating point when we're in production. So after we go through this, we have our contract, and this is preservation. And this preservation contract has a few things. So we have a few state variables that are being established here, along with this one here. So these state variables here, this comment came with the target. So their comment here is basically stating that these are public library contracts that have been established here. So we have an address. We have 3 addresses. So we have an address for time zone 1, address for time zone 2, and then we have an address for the owner. And then down here we have a uint. Remember, this is unspecified, so this is going to be 256. And this is going to be uint for stored time. Now, before we go to the next one, I've added these comments here, and I want to call these explicitly out. Because remember how I talked about storage within Solidity is stored into slots. Now, each one of these slots, we can see them, they're all established in order based off of the contract. So the first one here is going to be slot 0, and we know that we're going to go to slot 1 next, and this is taking up the entire slot because it's an address. So this address is going to take up the entirety of that slot 0. This address is going to take the entirety up of slot 1. This address here is the owner. That's going to take up slot 2. And you can see this, we're starting from 0. So we're counting from 0, 1, 2. And then slot 3 is going to be uint 256. So that's going to take up the third slot here. And understanding where those slots sit is going to be important for us to actually see what information is there and how we can adjust them over time. Below that, we have another state variable that's being established, which is bytes 4. And that's going to be labeled as set time signature. And then here what we're going to do is we're going to call a function at another contract, and we're going to encode that basically inside of a bytes 4 integer. And when we do that, we're going to put it in this variable so we can use it later on to do a delegate call down here that you'll see in a second. So those are the state variables at the top piece. Let's move down a bit and look at the constructor. So in the constructor, we can see a few things that are happening. First, when this contract's deployed via our constructor, the owner of this contract is going to basically put in an address for both time zone 1 and 2. And those are going to be set up into those variables that we've discussed above, time zone 1 here and time zone 2. And then we're obviously going to set the sender as the owner. That's going to be the piece there. And below that, we have two other functions. So this function is going to be set first time, and this one's going to be set second time. So they're going to be a similar process, different timestamps. So this first one here, we're going to put in a timestamp. When we put that timestamp in, it's going to do a few things. So it's going to call that encoded function that we discussed up here. So remember how we have set time signature? That's the same thing. So we're going to basically call the set time function on the library, and we're going to set the timestamp that's been input by us. Now all this stuff's going to be encoded and all that good stuff, and it's going to be a delegate call. So what that means is that when this set first time function is called, we're not actually going to do the execution here. Instead, set first time is going to delegate call. When a delegate calls, it's going to jump down here to this function, which is sitting in a separate contract. So you can consider this as a library. And it's going to then run the execution through here, and then that's going to be returned via this function. So we're going to delegate the call through this contract to another contract, which is going to be a library contract, to do some execution, and it's going to return the response there. And that's kind of how all this functions here. And that's how delegate call comes into play here, and how we're going to take advantage of this in a second. Time zone 2 is the same thing, so we don't have to really talk about this. All the same stuff, just a different timestamp. And then let's go down here to look at our contract quickly. So that, remember, like I said, this is a separate contract. So this is going to be a library contract. And the first thing I want to call out here that is an issue is that this is called a function set time, and it's not called a library. So when you look at some of the resources that I provide, when you set up a library, you don't necessarily want to call it a function, you want to call it a library. Reason being is that's going to help you understand that you can't store state and all that stuff, and it's going to put some guardrails on that both contract and function that you're using. So in here, pretty straightforward. So very small. We have a contract. It's setting a state variable, which is stored time. That's going to be in slot 0. And then we have our function that's basically going to take the timestamp that we provided up here. It's then going to run it through this function. It's going to take that time and put it in stored time, which will then reflect back up top here in the state variable that we set here. Okie dokie. So we just talked about a lot of stuff and talked through a lot of stuff. That's the target contract, and that's kind of what we're going to do here. The attack itself is very straightforward and very short. The contract is super short. So we can see this is the contract that we're going to use. This is our attack contract. It's only a couple of lines. And a few things to point out here. So we can see that in our contract, really all we did was we copy and pasted the 3 state variables from here. We put those into here. And then we copy and pasted the set time function from this library and put it in here. So the reason we did that is because when attacking a contract that hasn't necessarily set up their library correctly and they don't necessarily understand how state variables work within storage, we can actually manipulate those state variables if we kind of craft this in the right way. So our slot 0, 1, and 2 are identical to the other contract. So we're in line with them, so we can manipulate those when calling back. Additionally, our set time, instead of just doing straight up copy and paste, we're going to copy and paste it over, but we're going to actually add a different function in here than just setting the time. Instead, what we're going to do is we're going to set the owner of the contract to ourselves, the sender. And that's really going to help us manipulate that contract and take full ownership of it. So I hope that kind of glues and makes sense in your head. So we're going to execute this, and I think it'll make more sense when we actually go through this process. And the way that the logic's going to work here is, first things first, let's go to the target here. So first things first is we're going to call the set first time. When we call this, we're going to set this to, instead of a timestamp, we're going to set it to an address. And that address is going to be our attack contract. And once we've set this up, and we've set that as this time zone variable in slot 0, what we're going to do is we're going to call it once more. And once we call this once again, instead of doing the delegate call and having the delegate call go to the expected library, it's actually going to go out to our target address, or our attack contract. When it does that, it's going to execute the owner function, and then it's going to change our slot 2, and the owner will no longer be this address, but it'll be us. So let's do this. Let's do it. All right. So this is our same code, all good stuff, just in Remix. So you want to compile it, make sure there's no big errors. We're going to deploy this. All right. And actually, yeah, we can deploy it first. It's okay, it won't do anything. because I want to go in here and show you some stuff. Oh no, didn't mean to do that. All right, so if we go in here and check a few things. So let's check, all right, let's check the owner first, just to validate that we're not the owner. All right, so 97E, and we are not 97E, we are 3D5. And some other stuff that you can look at here that's publicly accessible, and you know it's publicly accessible by the public identifier here, is we can see the other addresses. So if we do time zone 1, we can see the address set for that, and we do the same thing for time zone 2, we can see the address for that. Now when we set the first time zone, when we run this through our address, this address for time zone 1 is going to change. And this is just one way of visualizing this. The way that we're looking at it is just strictly by calling the state variable. Another way that you can do this is actually by going through the get storage. And the way that this works is when you read the documentation and realize you take 3 variables, the address you want to look at, the slot position, and also I'm going to console log it out so you can see it. So if we do slot position 1 and we do enter, we'll see that this basically matches, it matches the 7DC here, 7DC here. And that's the same address sitting in slot 0. We can iterate through this, so we can do slot 1, we can see that this is going to match here, so we have EA0D, and this is going to be EA0D, so this is going to be time zone 2. And then we do the second one here, we can see that this is 97E, which represents the owner here. So you can see all those slots match up. And if we do slot position 3, there's nothing there. It's all zeroed out. So we know that we've exceeded and we passed that slot. Good stuff. So now that we've done this, we're going to run our attack contract. And we're going to change the first slot here. We're going to change this address from the address they provided in time zone 1 when they initially deployed the contract to our attack contract so we can then eventually take ownership. So now that we deployed this, what we're going to do is we're going to set the time, and we're going to set the time to our attack contract. But instead of running it in Remix, we can just run it here. So if we do contract set first time, we're going to set the first time to our attack contract here. So we're going to copy this contract address, and then we're going to set the time first. So once this deploys and once this completes this transaction, I'll show you that the address is actually changed here. Alright, so now that this is completed, let's run through this once more. And you can see, if we look, let me make it smaller, maybe you can see it. Alright, it's kind of tiny, but hopefully you can see this. That here we ran our slot 0, and here we ran our slot 0, and you can see this is D2D2, this is 7DC1, and these are different, right? And we changed that, and we adjusted that by setting the time zone for 1. So if we go back to our address here, you can see that this is D2D2. So now currently, time zone 1 is set to our attack address. Now that we have our attack address and our attack contract set up, all we have to do is call this one more time, and we can call it with whatever value we want. It doesn't really matter what it's set to. So we can say 86, what is it? It's 8675309. If you know that song, put it in the comments. All right, so if we put enter here and we confirm this, what should happen is that when this is executing, remember, we've already set our address as the time zone 1. We're going to call it again, and once we've called it again, ideally, this value we put in here, it's going to run the delegate call, and it's going to then call our contract. So when it does that, it's going to then go down to our contract. It's going to do the set time, but the set time is going to be deceiving because we've mimicked what they've encoded here, so they expect it to be the same, but in all reality, we're going to change not the time, but the ownership of the contract. So now that this is completed, if we do await contract.owner, we'll see that this is now 3D5, which is our address. So if we submit this, we should get a bunch of confetti and happy faces because we've beat the challenge. And there it is. We did it, Internet. We've completed preservation. Thank you for joining me on this amazing journey, and level 17 is going to be recovery. I'll see you then.